Okay, so good morning, good day, grade 8 Makati Science High School students. For our sixth and last lesson for the third quarter, we have here the special right triangles, 30, 60, 90 right triangle, a 45, 45, 90 right triangle. We're also going to be discussing the 6 trigonometric ratios and also a bit of an introduction to angles of elevation and depression. Okay, so as you can see here, guys, so we're delving much deeper into trigonometry in preparation for your trigonometry class in grade 9. Okay, so we have here a sort of introduction for our lesson, the Deathly Hollows. Okay, so that's we have here the symbol of a Deathly Hollows. So we have here a triangle and then the elder one, the resurrection stone at the middle. So there you go. You can see two right triangles, okay, that's being separated by this angle bisector here, PY. So that could be the elder wand, okay, creating two right triangles. So given the symbol of the three Deathly Hollows in Harry Potter, what type of triangle is triangle HPE? Okay, so given that we have here the symbol, what do you think is triangle HPE? Is it an equilateral, a scalene, or an isosceles triangle? So you can write that as your answer. And given right triangles HYP and EYP, what type of special right triangles would they be? Okay, so what do you think are the types of special right triangles HYP and EYP would be? Okay, and you can explain it. Okay, so there you go. So that's the preliminary activity, and as we have seen here, okay, so that's application of popular culture. Okay, so in popular culture, we can see a lot of what they call this applications of geometric objects. Okay, and especially right triangles. So we can also use special right triangles in real life, okay, so mostly used for art and design, and on your smartphone, okay, on our laptops or in any device that we have, we will have a right angle, okay, so that's going to be 90 degrees, and if we cut a triangle on that specific device, so therefore we will have formed a special right triangle that can follow the patterns of a 30, 60, 90 right triangle or a 45, 45, 90 right triangle. Okay, so and also in GeoGebra, using GeoGebra, we can try to map and find the properties of these special right triangles. Okay, so what is a special right triangle? It's a right triangle that follows a specific pattern. The first one is a 30, 60, 90 triangle. So this one, if we have here triangle GOA, okay, so the opposite of 30 degrees, okay, will always be S. Okay, so it's going to be equal to 1S. And the opposite of the 90-degree angle or the hypotenuse would be 2S. Okay, and if we have here, for example, a 60-degree angle, it will be equal to square root of 3 times S, where S is the side measurement of the smallest side in a 30, 60, 90 right triangle. Okay, so let's try to make that more concrete. Okay, so let's draw another example here at the bottom. Okay, so we have here triangle FIG. Okay, triangle FIG. Okay, so let's say for example we have here a 90-degree angle, a 30-degree angle, and a 60-degree angle. Let's say we're only given this measurement side IG. Okay, so side IG is equal to, let's say, 10 centimeters. So we want to know the side measurements of the hypotenuse FG and the longer leg FI. So what are their measurements? So using the special right triangle theorem, okay, so the 30, 60, 90 triangle, so we can say that FG is equal to 2 times S, okay, and S is equal to, again, 10. Okay, so that's the value of IG, okay, which is 10. So 2 times 10, that will simply give you 20 centimeters. And FI will be, okay, square root of 3 times S, and again, the value of S is equal to 10, so that's going to give us square root of 3 multiplied by 10. And therefore, the value of Fi is 10 square root of 3 centimeters. Okay, so that's simple using the 30, 60, 90 triangle. So if IG is equal to 10 centimeters, then FG is equal to 20 centimeters, the double of the shortest side in a 30, 60, 90 triangle, and FI is equal to, okay, FI is equal to 10 square root of 3 centimeters. Okay, so that's simple. Okay, so let's go next. Okay, so let's try to solve some problems involving the 30, 60, 90 triangle. So find the values of R and S given that the side and angle measurements of the 30, 60, 90 triangle is given on the image on the right. So we want to find the measurement of R and S. We're only given the hypotenuse. The hypotenuse, okay? The hypotenuse is equal to 10 centimeters. Okay, so we have here the 30-degree angle is here. Okay, so if the 30-degree angle is here, and we have here 10 centimeters, this is 60 degrees, 30 degrees, and 90 degrees. Okay, so if the value of the hypotenuse is 10, so 10 must be equal to 2s, and therefore s must be equal to 5. And this is the value of the S, or the shortest side measurement. Okay, so this is 5 centimeters. Okay, so S is equal to 5 centimeters. And to find the value of R, okay, so R is just going to be simply equal to, okay, R is simply going to be equal to square root of 3 times S. And S, we've already solved for the value of S, so R is equal to 5 times square root of 3, okay, centimeters. Okay, so there you go. So the value of R is simply equal to 5 square root of 3 centimeters. That easy. Okay, so let's try to solve the second problem that we have here. We need to find the values of WQ for the image that we have here. So again, this problem, guys, it's really centered on the most important thing, or the thing that we have to focus on here, is the position, or the relative position of the angles that we have. If we have here the 90-degree angle, so this must mean this is the hypotenuse. The hypotenuse must be equal to Q, and therefore its side measurement must be 2 times 15. Okay, since the shortest side, 30 degrees, okay, is equal to 15 centimeters. Its opposite side is 15. So therefore, the hypotenuse will give you 30 centimeters. This is the value of Q. And we have here W. So how do we solve for W? Since we know that the shortest side, okay, let's call it S. Okay, the shortest side is equal to 15 centimeters. Okay, so we have here 60 degrees. So therefore, W will be equal to square root of 3 times the value of S. And again, we know the value of S is equal to 15. So this means that W is equal to 15 times square root of 3. Okay, so centimeters. So this will give us 15 square root of 3 centimeters. Okay, so there you go. That's simple. Okay, so therefore the value of W is equal to 15 square root of 3 centimeters, and the value of Q is equal to 30 centimeters. Okay, so another special right triangles, if we have the 30, 60, 90 right triangle, we have the 45, 45, 90 right triangle. So it follows the pattern 45, 45, 90. So two 45-degree angles and a 90-degree angle. The very noticeable thing about this one is it has two congruent side measurements. Since there are two congruent angles, then the sides opposite those angles must be congruent also. So therefore, we will have formed a isosceles triangle. We will have formed an isosceles triangle here, triangle FAR. So it's an isosceles triangle. So since the two side measurements are the same, so that's just going to be simply S and S. So the only side that we have to measure is the hypotenuse, and the hypotenuse is simply equal to the square root of 2 all over S. Okay, so let's try to apply this theorem on concrete examples. Okay, so using the 45, 45, 90 triangle, let's say for example we have here a triangle. Okay, let's name this triangle. It doesn't have a name. Okay, let's say its name as dog. Triangle dog, D-O-G. Okay, so let's say for example we want to find the value of DG and DO. Okay, so how do we find the measurements of sides DG and DO? Okay, so we have here the measurement of the 45, 45, 90 degree triangle. Its side measurement, one of its sides measure 9 meters. Okay, so if that's 9 meters, if OG is equal to 9 meters and OG is equal to DG, since this is a 45, 45, 90 triangle and it's an isosceles triangle, therefore DG must be equal also to 9 meters. And to solve for the value of DO, or the value of U, okay, so therefore T is also equal to 9 meters. So to solve for the value of U, or DO, okay, so we simply have to use the pattern that we have, or the formula that we have here. So the hypotenuse is equal to square root of 2 times S. So therefore we have here DO is equal to square root of 2 times S. And we know that the value of S, okay, so S here is T, okay, T is equal to 9 meters. So that's going to be square root of 2 times 9. So therefore the hypotenuse is equal to 9 square root of 2 meters. Okay, and that's simple. Okay, or the value of U, okay, the value of U is equal to 9 square root of 2 meters. Okay, very simple. Okay, let's move forward. In a rectangle ABCD, F is on diagonal BD, so that AF is perpendicular to BD. Also BC, okay, let's try to write the measurements. BC is equal to 30, CD is equal to 40, and AF is equal to X. We need to determine the value of X. Okay, so as we can see here, guys, we have here two triangles. Let's write here our two triangles. We have here triangle ABD and triangle ABD and DBC. Okay, so to solve for the area, okay, so let's try to solve for the area. To solve for the area of both triangles, we can use the formula. The simple formula, A is equal to 1/2 base times height. Okay, so we already have the base, okay, for DBC. We already have the base, which is 40. Okay, so A is equal to 1/2. Okay, so that's simply equal to 40. Okay, and the height is equal to 30. So therefore, A is equal to 1/2. Okay, 1/2 of 40 times 30. So that's going to give you 1,200. Okay, so let's just check. Okay, 40 times 30. That gives you 1,200. And therefore, the area of DB is equal to 600 units squared. Okay, so since the area of DBC is just similar to ABD, so therefore we can solve for the value of, okay, we can solve for the value of B here. Okay, so the value of B is just going to be the hypotenuse of the triangle DBC. So to solve for the hypotenuse, we're just going to use the Pythagorean theorem. So BD squared is equal to DC squared plus BC squared. So this is going to be 40 squared plus 30 squared. So that's going to give us 1,600 plus 900. So that's going to give us 2,500. Yeah, 2,500. Okay, and the square root of 2,500 is equal to 50. Okay, so therefore BD is equal to 50. Since BD is the base, okay, it's the base of triangle ADB, so therefore we can write here 50. We just have to solve for the height. Okay, and we know also that the area of this one of ADB is equal to 600. Okay, so therefore we can solve for the value of H. So we have here 600 is equal to 25H. Okay, so if we divide both sides by 25, okay, so therefore the value of H, okay, is equal to, the height is equal to 24. Okay, 24 units. Okay, and therefore the value of X is equal to 24 units as well.